Now that we have a better idea of what the reader interface does and what specifically the read function does, let's try putting together a little bit of code that creates a byte slice, passes it to the read function that the response body implements, and then see if we can't take that byte slice and print out all the data that was added to it by the read function. So I'm going to change back over to our code editor. I'm going to find the line where we were logging out the entire response and delete it. And then we'll start off by creating an empty byte slice. So this byte slice's purpose is to hold all the data that gets written into it by that read function. So we're going to declare this byte slice with slightly different syntax than what we've seen previously. You'll recall that in the past, we declared all of our slices by saying something like, here's my square braces to indicate that I want to make a slice. Here's the byte type to indicate that I want every element in the slice to be a byte. And then we listed out inside of curly braces all the different elements to add to the slice. So this time around, we're going to use a slightly different syntax. So I'm going to delete that, and instead we're going to say make a slice of type byte and make sure that there are 999999 elements available inside of it. And you know what, actually let's do just 99,999, like so. So this make function right here is a built-in function in the language that takes a type of a slice, and then as a second argument, this is the number of elements or empty spaces that we want the slice to be initialized with. So remember, we spoke a lot about slices just a little bit ago and how they work with underlying arrays. So yes, a byte slice can grow and shrink, but if we want to, we can create a byte slice with n number of empty elements inside of it. And so this line right here specifically says, give me an empty byte slice that has space for 99,999 elements. And you'll see why in just a minute. Okay, so now here's what's going to happen. We just made our empty byte slice. It has 0 through essentially n empty elements inside of it. We're now going to pass this off to the read function. The read function is then going to take some source of data, so the actual HTML that's contained inside the request, and stick all that data into this empty byte slice. Now, just to be clear, the reason that we initialized the byte slice with this giant amount of capacity inside of it is because the read function is not set up to automatically resize the slice if the slice is already full. So essentially, the read function is just going to read data into the byte slice until the byte slice is full. And so if we initialize a byte slice with like 0 elements inside of it, the read function is going to say, oh, this thing is already full. I can't read any more data into the byte slice, so I'm just going to quit early. So instead, we take this approach of just making an arbitrarily large byte slice that's basically big enough for all this data to fit into. And so we're really just taking an educated guess here and assuming that 99,999 spaces or elements inside the slice is enough to accommodate the actual piece of data that we're working with here. Total assumption. Okay, so now right underneath this, we'll look at the response struct. We'll get the body property off of there, which is the value that implements the reader interface. And because it implements the reader interface, we know it has access to the read function. And even the autocomplete is kicking in here and saying, hey, this thing has a read function. So I'm going to click on read, we'll call it, and then we're going to pass in that byte slice right there that we just created. So now the response body should take the byte slice, take its HTML that is contained inside the body, and read that data into the byte slice. And so immediately after that, we'll print out, print line. We'll print out the actual byte slice. Now remember, whenever we see byte slice, we can essentially think of a string. And so before we actually print it out, I'm going to turn this thing into a string by wrapping it with the string type, like so. Okay, now let's save this and run it and see what happens. So I'll run go run main go. And sure enough, we get all the HTML that forms the actual google.com homepage. So you can scroll up a little bit, and eventually you're going to see the doc type HTML at the very top. Here it is right here, doc type HTML. Here's the HTML tag, here's the head tag, and all the other stuff. So yes, printing out and working with this reader interface definitely is not the most straightforward thing in the world, but again, it really is saving us from the lesser of two evils, essentially. It's saving us from having to write a bunch of different custom functions specifically for working with, something that's coming out of the body of some ridiculous custom type here. Now, as you might imagine, in reality, we do not actually always make some byte slice like this and pass it off to the read function whenever we want to read data out of a response. So the language Go does have a lot of built-in helper functions for automatically working with reader interfaces and essentially getting data out of this reader interface or this reader type right here and getting it to show up at the terminal. So we're going to take a quick break right now. We'll come back in the next section and we're going to look into some approach that will dramatically simplify the amount of code that we have to write right here. So quick break and we'll come back and condense this thing down in the next video.